Any data science project starts with data collection process. Atlic Agriculture has three options of collecting data. First, we can use ready-made data. We can either buy it from third-party vendor or get it from Kaggle, etc. Second option is we can have a team of data annotators whose job is to collect these images from farmers and annotate those images either as a healthy potato leaf or having a early or late blight disease. So this team of annotators can work with farmers. They can maybe go to the farmer fields, and they can ask farmers to take the pictures, or they can take pictures themselves, and they can classify with the help of farmer or by some means, by domain knowledge, that okay, these are classified as diseased potato plants versus the healthy potato plants, so they can manually collect the data. This option is expensive, it requires budget, so you have to work with your stakeholders and kind of get the budget approved, and it might be time consuming as well. The third option is data scientists can write web scraping scripts to go through different websites which has potato images and collect those images, and then use the tools like Docano. There are so many tools that are available which can help you annotate the data. So either you annotate that or you get annotated images by using those web scraping tools. In this project, we are going to use ready-made data from Kaggle. We will be using this Kaggle dataset for our model training. You can click on this download button. It's 329 megabyte data, whatever. And it has not only the images for potato disease classification, but some tomato and pepper disease classification as well. We are going to ignore all of this. We will just focus on these three directories. So I had already previously downloaded this zip file. When I right click and extract all, I get this folder, and in this folder I had the tomato, all these directories, but those directories I have deleted. So I deleted those directories manually. So I asked you to do the same thing. Go here, delete all the directories except these three. Then you will copy paste this directory into your project directory. Now for project directory, I have C code folder, and here I am going to create a new folder called potato disease. So I want all of you to practice this code along with me. If you just watch my video, it's a waste of your time. You practice as you watch this video, only then it is useful. This is the best advice that someone can give you. Okay, I have this folder ready for my project, and in that I'm going to create a new folder called training. Okay, and then I'm going to launch git bash. So I have this git bash which allows me to run all the Unix commands. You can use Windows command prompt as well, and I will run python -am notebook, which is gonna launch my Jupyter notebook here. And in this I will locate my potato disease folder, go training, create a new Python 3 file, and this will be my model. Okay, so you can say, okay, training, whatever, just give some name to this particular notebook. And then we are going to import some essential libraries. So the purpose of this video actually is to download the dataset into tf.Dataset, tf data input pipeline, and then we will do some data cleaning, and we will make our dataset ready for model training. So that's the purpose of this video. So here, let me download some essential modules here, and then the first thing I'm going to do is, okay, so we had this. Okay, so in the download, my download folder, somewhere I had this plant village directory, right? So plant village directory, I'm going to do control C and then control V here. So I will copy all those images into the same folder where I'm running this notebook, my IP1NB notebook. So you see, now I have this directory, and if you look at all this, This is like early blight. So there are 1,000 images here, and if you look at all these images, you see there are these black dots. So this is showing that this potato plant has some kind of disease. If you look at healthy plants, healthy leaves are healthy, there are no black spots and they look pretty good. The other one, late blight, will also have. Late blight is a little more deteriorating. See, you look at all these leaves, they look pretty horrible. So we have all this data here in our directory, and now I'm going to use TensorFlow's dataset to download these images into tf.Dataset. Now, if you don't know about TF dataset, you need to pause this video right now. Go to YouTube, search for TensorFlow data input pipeline, and you will see my video here. You need to watch this video. It will clarify your concepts. Basically, what's the purpose of tf.Dataset? Let's say you have all these images on your hard disk, okay? And you can download these images into batches because there could be so many images, right? So if you read these images in batches into this tf dataset structure, then you can do like dot filter, dot map. You can do amazing things. So please watch this video, and I will now assume that your concepts around tf datasets are clear, and we can now load that data using tf dot, like this particular API. So tf.kera.preprocessing image data set from directory. Okay, now, okay, what does this do? So you can search TensorFlow image data set from directory. It will show you an API for this directory. So you specify a directory first. So let's say you have main directory, you have your classes, and these are all the images. So this one call will load all the images into your tensor, basically into your data set. Okay, so the first argument is what? Directory. Okay, what is our directory? Okay, so let me write this here. Our directory name is plant village, correct? See, plant village, that's our data directory. Then I will say shuffle is equal to true, so that it will just randomly shuffle the images and load them. And then I will say image size. Okay, what is my image size? So let me go here and open this directories. Like if you look at this image size, you see 256 by 256. All of these images are 256 by 256. You can verify that. So I will say 256 by 256, but I will store, I will create couple of constants where, because I need to refer to these constants later. So I will say, okay, 256 by 256 is my image size. My batch size, 32 is kind of like a standard batch size. I will again store that into a constant and initialize it here. And that's pretty much it. I will just say store this into a data set. Okay, okay, that's wrong. Okay, I did not run this. Okay, so it loaded 215 files belonging to 3 classes. Well, which 3 classes? So you can just do this dot class names, I will just store that into a variable so that I can refer to it later. And these are the class names. Basically, your folder names are your class names. See, these are the 3 folder names. And if you look at this has 1,000 images. The second one has 152. Third has 1,000. So 2,152. And look, if I do length of dataset, do you have any clue why is it showing 68? Just think about it. Pause the video, think about it. Because every element in the dataset is actually a batch of 32 images. So if you do 68 into 32, see, the last batch is not perfect, so it is showing little more than 2152 images, but you got an idea why this is 68. Okay, let's just explore, I would say let's just explore this data set. So I will say for images batch, for okay, for image batch, label batch in dataset.take. When you do this, it gives you one batch is how many images? 32 images. Okay, so I will print just the shape of this thing. I will say shape this, and labels batch dot. I will just do, see, numpy, like every element that you get is a tensor, so you need to convert that to numpy. Again, if you don't know the concept, refer to the video that I talked about earlier, and you find that there are 32 images. Each image is 256 by 256. Do you know what is this? You guys are smart. It's RGB. It's channels. Basically, you have RGB channels. So it's basically 3 channels. And I'm going to initialize that as well here so that, I can refer to it little later. And these images label batch has, you already realize 0 1 2. So this is 0, this is 1, this is 2. So there are 3 classes, 3 images. And if you are, if you want to print, let's say, each individual image, so I will, okay, forget about this, I will just print first image. This has 32 images. I will print first image. So for first image, you see it's a tensor. If you want to convert tensor to a numpy, you do this, and you find all these numbers 3D array. Every number is between 0 to 255. The color is represented with 0 to 255. So that's what this is. Okay, and again, if you do shape of this, you'll find 256 by 250 by 3. Okay, first image. Got it. All right, now let's try to visualize these images. Okay, let's say I want to visualize this image, so I can use plt.imshow. So this is matplotlib. Okay, plot C, matplotlib, and when you do imshow, it expects 3D array. So what is my 3D array? Well, my 3D array is this. So I'm printing, by the way, the first image. Okay, so numpy. Okay, there is some problem. So what I need to do is, it is float. So I converted it to int, and now you see it working. Okay, I don't care about all these numbers, so I will just do, I will just, hide that. And by the way, every time it is shuffling, so that's why every time you're seeing different image, because it has shuffle randomness to it. Axis is off. Now I want to display the label, like what image is that. So how do I display that label? Well, you can do plt dot title. Okay, and what is my title? Well, my title is label batch. Okay, this is my title, but this will give you number 0 1 2. How can you get the exact this class name? Well, we have class name, so you supply that as an index. I hope you are getting the point. See, potato early blight. Okay, I want to display a couple of these images, so I will just run a for loop. I'll say maybe I want to display out of, first batch is 32. I want to display let's say 12 images, and instead of this I will say I. Got it? Okay, I hope that is clear. And if you want to show this in a, see, if you run this, it's gonna, so it's just showing one. Why? Because you need to make a subplot. So subplot 3 by 4 is like almost like a matrix. And if you do this, okay, it shows all the images, but the dimension is kind of messed up, so I will just increase the area, of each of these images to 10 by 10, and look, wonderful, it just shows me all the images beautifully. This is healthy leaf, see, this is early blight, late blight, and so on. Now we are going to split our data set into train test split. Okay, so let's say data set length is 68. Actual length is, by the way, 68 into 32 because each element is 32 batch. Okay, now what we will do is we will keep 80% data as training data, then we get remaining 20%, right? In remaining 20%, we will do two split. So one 10% split we will do validation, and remaining 10% will do test. So this validation set will be used during the training process. When you run each epoch, after each epoch, you do validation on this 10%. Okay, so you run, let's say, let me define the epoch. So I am going to run 50 epochs. This is trial and error. Okay, you could be 20, 30. So we'll run, let's say, 50 epochs, and at the end of every epoch, we use this validation data set to do the validation. Once we are done through 50 epochs, once we have final model, then we use this 10% data set. This is called test data set to measure the accuracy of our model. Before we deploy our model into the wild, we want to use this 10%. Before we deploy our model into the wild, we'll use this 10% test dataset to test the performance of our model. Now, how do you get this split? In sklearn, we have train test split method. Train test split. If you use statistical machine learning in sklearn, we have that. We don't have that in TensorFlow. We are going to use dataset.take. So when you do dataset.take, okay, let's say 10, it will take first 10 samples. Now, what is our train size? Okay, so training size is 0.8 because it is 80%. Okay, and what is the length of our data set? 68. Okay, I'm going to say, okay, what is 80% of 68? Well, 54. So I can now take first 54 samples, first 54 batches, actually each batch is 32, so it's much more sample, and call it a train data set. Okay, so that's my train data set. And if you do a length, I hope you are practicing along with me, you find 54. And if you do dataset dot skip 54, it means you are skipping first 54 and you are getting remaining 54. This is like if you have used the slicing operator in Python list, it is like 54 onwards, and this one is like first 54. Okay, so I hope if you know Python a little bit, this should be clear. And this one, okay, so first data, okay, so this will be my test data set. Actually, this is not test data set, so this will give you remaining 20%. In that, you need to again split into validation and test, correct? So I mean, temporarily I will save it as a test data set, but this is not exactly test data set. I have 14, and out of that, my validation size is what, 10%. Okay, and what I'm doing is 10% of my actual data set is 6. So I need 6 samples basically from my test data set, and when I do that, I get my validation data set. And if you do validation data set, that is 6 samples, and then you will do skip, and that will be your actual test data set. So we just split our data set into validation, test, and train data set. Now the code I wrote was using all the hard coded numbers, and doesn't, it's just a prototype. So you want to wrap all of this into a nice looking Python function. Let's call it this function. And that function, the goal of this function is to take the TensorFlow dataset. Okay, it should also take what is your split ratio. So I'm just saying, if you don't supply anything, by default it will say 80% train, 10% validation, 10% test. And I'm also going to do shuffle. I'll explain why. And shuffle size is 10,000. If you don't know about shuffle size, again, watch to my other video that I referred. It's very important you watch that. Okay. Now, what I will return in the end is this. So we are doing whatever code we are doing, we are just creating a nice looking Python function. That's it. Okay. So my train size is, okay, what is my data set size first of all? So my data set size is this length of data set. Then my train size, my training size is train split, like 80% of this, and I want to convert it into integer because see, I don't want to get these float numbers. That's my train size. And my validation size is this. Okay. All right. Now my train data set is basically whatever we did previously, which is, ds.take train size. And then when you do ds.skip train size, you get remaining 20% samples. In that, you will again take validation size, and that's where you get your validation data set. And if you do the same thing and just do skip here, you get your test data set. Okay, so I hope that is clear. Now we have shuffle argument. So if shuffle, I want to just shuffle the data set, so that before we split into train test split, the shuffling happens. And seed is just for predictability. If you do same seed every time, it will give you same result. This is just a seed number. It can be anything. It can be 5, 7, anything. Okay, my function is ready, and I can now call my function on my data set. Okay, what is the name of my data set? Here is my data set. You see, data set. So we read all the images into this data set. Now we are doing train test split. Train test split, sorry. Okay, see, this ran like, it ran so fast. And I will just confirm the size of my validation set, my test set, and so on. And they are coming to be what we expect it to be actually. Now, once again, if you have seen my video on TensorFlow data input pipeline, you would have understood the concepts behind caching and prefetching, etc. So that's what we are going to do here. So we are the training data set that we have. We will first do caching. This will, it will read the image from the disk, and then for the next iteration, when you need the same image, it will keep that image in the memory. So this improves the performance of your pipeline. Again, watch that video because you will get good understanding on this. Shuffle. Okay, how shuffle 1000 works, again, you need to watch that video. So shuffle 1000 will again like shuffle the images. I think this, since our, yeah, it can be less than 1000 as well. But anyways, and then prefetch. Prefetch, if you're using GPU and CPU, if GPU is busy training, prefetch will load the next set of batch from your disk, and that will improve the performance. Actually, if you look at my deep learning playlist, I have prefetch and cache video here. So this video talks about prefetch and cache, and I can quickly show you. So usually when you are loading batches, let's say 32 images at a time, and I have a GPU Titan RTX. When it is training, you know, you are not reusing CPU when the GPU is training because CPU is sitting idle. Then when you're done, now CPU again reads the batch and GPU is idle. So this, let's say for this example, it takes around 12 seconds. But if you use prefetch and caching, so what's gonna happen is, see, uh, when you use prefetch and caching, while GPU is training batch 1, CPU will be loading that batch. You see? So that's your prefetch basically. And your cache is something where, okay, so this is prefetch, and cache is basically if you have read an image. So see here, I think um, usually see you read an image, so this is that blue dot, and during the second epoch you are reading the same images again. Okay, but if you use cache here, you don't see this blue block here, so you save time reading those images. So go to, I will link all these videos by the way, but if you do code basics deep learning tutorials, these are the two videos I am referring to. So back to the tutorial once again. So that's what I'm doing, and here I'm letting TensorFlow determine how many batches to load, while GPU is training, and then you can load this here. Okay, now my validation and test data set again will use the same paradigm, and now these data sets are kind of optimized for training performance, so my training will run fast. Now we need to do some pre-processing. You all know, if you have worked on any image processing, the first thing we do is scale. So the image, the numpy array that we saw previously was between 0 to 255. It's an RGB scale. You want to divide that by 255 so that you get a number between 0 and 1. And the way you do that is by doing tf.Dataset. Okay, and here I'm supplying my pre-processing pipeline. Okay, so the way you do rescaling is by using this API. Now don't worry about experimental, by the way, this is stable. Okay, I had a conversation with TensorFlow folks actually on this. They're saying it is stable, so don't worry. 1.0 divided by 255, this will just scale the image to 255, and we will supply this layer when we actually build our model. Okay, we need to do one more thing, which is resizing. We'll resize every image to 256 by 256. So this will resize the image. Now you will immediately ask me, our images are already 256 by 256. Why do we need to resize it? But this layer that we are creating, okay, see, let me create this layer. So this resize and rescale layer will eventually go to our ultimate model. And when we have a trained model and when it starts predicting, during prediction, if you are supplying any image which is not 256 by 256, some different dimension, this will take care of resizing it. So that's essentially the idea here. Once we have created this layer, one more thing we are going to do in terms of pre-processing is use data augmentation to make our model robust. Let's say you train a model using some images, and then when you try predicting, at that time, if you are supplying an image which is rotated or which is different in a contrast, then your model will not perform better. So for that we use a concept of data augmentation. In YouTube, you search for TensorFlow data augmentation, you will find my video. You must watch that video. What we do in that is, let's say you have this kind of original image in your training data set. You create 4 new training samples out of that. You apply different transformation, let's say horizontal flip, contrast. You see contrast is increased in this image. So you're taking same image, you're applying some filter, some contrast, some transformation, you are generating new training samples. See here I rotated the images, you see, and I will use now all 5 images for my training. So I have one image, I create 4 extra image, I use all 5 images for my training so that my model is robust. Tomorrow when I start predicting in wild, if someone gives me rotated image, my model knows how to predict that. Okay, so that's the idea behind data augmentation. And if you have seen that video, TensorFlow provides beautiful APIs. Again, you're doing same thing where you're creating couple of layers, and I'm going to apply a random flip and some rotation. If you watch that video, the other video, you will get a clear understanding. So that's my data augmentation layer, which I am going to store here. And by the way, resize, rescale, all these layers I'm going to use ultimately in my actual model. So I had only this much for this video. In the next video, we are going to build a model and train it. In this video, just to summarize, we loaded our data into TensorFlow dataset. We did some visualization, then we did train test split, and then we did some pre-processing. We have not completed pre-processing. We just created layers for pre-processing, by the way, and we will use these layers into our actual model. I hope you're liking it. I hope you're excited to see the next video coming where we'll be actually training the model. It's gonna be a lot of fun. If you're liking this series, please share it with your friends. Give it a thumbs up. See, when you give it a thumbs up, it helps me with YouTube ranking, and this project can go to more people who are trying to learn. And the thing about YouTube is, the learning is free. So if you're doing free learning, at least you can give it a thumbs up. I mean, give it a thumbs down if you don't like it. I don't mind it. But if you give thumbs down, please leave a comment so that I can improve. Thank you for watching.